Hey YouTube, in this video we're going to take a look at deploying a Laravel application towards multiple servers without any downtime using GitHub Actions. Before we dive in, my name is Philo and you're actually watching my very first YouTube video about which I'm both excited and also a little bit nervous. I'm a self-taught developer and my journey started 20 years ago with front page. Anyone who remembers that? Kinda makes me feel old. Anyways, I've decided to dedicate 2021 towards sharing what I've learned over the years. Learning how to program, getting started as a freelancer, but also co-founding a startup and the roller coaster that awaits you when you get your first investment. But let's leave that for future videos and get started with deploying our application towards multiple servers without any downtime using GitHub Action. Let's start with a quick introduction to GitHub Actions. GitHub Actions allow you to trigger a workflow when specific GitHub events occur. For example, you can run a test suite when a pull request is made. Or in our case, create a build of our product and upload it to multiple servers when a commit is pushed to our master branch. Our first step is to create a new repository on GitHub. So I'm going to create a new repository called Hello World. I'm going to make it private and I'm going to create it. Okay, so in this example, I'm going to use a plain Laravel installation, but you can use any project that you want, whether it's a WordPress website, a static website, it doesn't really matter. You can just follow along and adjust accordingly. So I'm going to switch over to my terminal and I'm going to use the Laravel installer to install a plain version of the framework. Next, I'm going to add our GitHub repository to our local environment so we can easily push to GitHub when we make changes. Now let's add the code that we have so far. And let's push it up to GitHub. Okay, so we have our repository set up. Now we can move over to creating our workflow. Let's open up our editor and let's create our first workflow file. GitHub Actions uses a YAML syntax to define the events, jobs, and steps. These YAML files are stored in our repository in a directory called .github/workflows. So let's create that now. Create a new file, type .github/workflows, and you can name your workflow file anything you want. In this case, I'm going to name it deploy application.yaml. Like I mentioned, GitHub uses a YAML syntax. So we're going to first define a name. I'm going to call our workflow deploy application. Next, we want to define the trigger that's going to trigger this workflow. So I'm going to say on push. And I only want this event to trigger when a push has been made on the master branch. Next, we're going to start with our first job. We basically want to prepare our application so that it's ready to be run on the production environment. In this case, we're using Laravel, so we want to make sure that we compile our CSS, our JavaScript, and install our PHP Composer dependencies. Let's start off by giving an identifier to a job. Let's call it create deployment artifacts. Next, we're going to provide it with a name that's going to be displayed in the GitHub interface. Let's call it create deployment artifacts. Next, we're going to define our runner. Our runner is basically a server that has the GitHub Actions runner application installed. In this case, we're going to make use of a runner that is hosted by GitHub, and we're going to choose Ubuntu latest. Now we can continue by defining the steps that we want to execute on our runner, in this case on the Ubuntu latest environment. So we're going to start off by importing our repository code. By default, it's a empty OS, so it's just Ubuntu with no source code whatsoever. So in our first step, we're going to make use of an existing action. In this case, the checkout action, which is provided by GitHub, which allows you to check out your source code into your runner with just a single line of code. So now that we have our source code, we can continue by pulling in our npm dependencies. compile our CSS and JavaScript. So start off by giving it a name. And next, we're going to use the run parameter to define a command that we want to run inside our runner, which is Ubuntu latest. So by using the pipe character, you can enter multiple lines. So in this case, we want to do npm install and npm run production. This will install our npm dependencies and compile our CSS and JavaScript. Let's push the changes that we have so far up to GitHub and let's see what happens. When you switch to GitHub, you'll notice this orange indicator. This indicator tells you that a workflow is currently running. So when you click Actions, you will get an overview of all your previous workflows that have been executed and the ones that are currently running. And as you can see, our workflow is currently in progress. Click it, and you will get some more information about the different jobs which exist inside this workflow. In this case, our create deployment artifacts. With the power of video editing, I'll make sure that I cut out any waiting time so you don't have to wait for every workflow to be completed. Our first workflow has just completed. Let's take a look and see what has happened. Here you get an overview of all the different steps inside the create deployment artifacts job. You can see that it has a setup job, which is defined by GitHub. And you can see that it's downloading the required actions that we define in our workflow. In this case, it's calling the checkout action. And you can see that it checked out our Hello World repository. Next, we got our compile CSS and JavaScript step. And here you can see that it downloaded our npm dependencies and it successfully compiled our JavaScript and CSS. Okay, next up, we want to make sure that our runner is configured with the correct version of PHP. In this case, we're going to configure it with PHP version 8, and we're going to make sure that certain PHP extensions are enabled, which are required by Laravel. In this case, we're going to make use of a community build action. This action is going to help us to configure PHP inside our runner with just a few lines of code. So let's reference the action that we want to use and let's provide it with the required input parameters. Let's define our version of PHP, which is 8.0. And now let's define the extensions which we want to include. In this case, Laravel requires MB string, C type, file info, OpenSSL, video, math, JSON, tokenizer, and XML. Let's commit these changes and push them up to GitHub and see if it works. Switch back to our actions, and as you can see, a new workflow has been queued. Let's forward to the output of our PHP configuration. Here you can see that it found version PHP 8. It set up a composer, which we need to install our dependencies, and then it enabled the extensions which we defined in our YAML file. So now that we have PHP configured and Composer installed, we can install our Composer dependencies. So let's create a new step and let's call it install Composer dependencies. Next, we want to run a command inside our runner. We're going to do Composer install, no dev, because we don't want any dev dependencies on production. We add the no interaction flag because it's an automated process, and we want to state that we prefer the distribution source. Okay, so let's quickly commit these changes and take a look. Again, going to speed up this a little bit in post-production. And there you can see our PHP Composer dependencies have been installed successfully. Okay, great. Our build is complete. So now we can prepare it to be shipped to our remote server. In this case, I want to create an archive of the entire application. So we just have one file to work with. Okay, let's name our next step. Let's call it create deployment artifact, followed by the command that we want to run inside our runner. In this case, we're going to create a archive. We're going to use the tar command with the C flag to tell it to create a new archive. We're going to use the Z flag to tell it that we want to use gzip compression. And we're going to use the F flag to define that we want to have the output in a file. Let's name the file app.tar.gz. Now, what will happen? It will create an archive from all the files in our current directory. And as you remember, we've installed npm dependencies that we actually only needed to create this build. So we want to make sure that these files are not included in our archive. We can achieve this by using a exclude flag. And we can define a pattern that we want to use to exclude, for example, the Git directory, or in this case, the node modules directory. Let's push these changes up to GitHub and verify that the results are as we expect. The job has been completed. You can see that the command has successfully executed. Since we're pushing this file up to our remote server, the file name app.tar.gz is a little bit unclear. We're not sure which release is actually inside. So I want to make sure that we can identify each release by naming the file of our archive and make sure that it's equal to the commit hash. We can do this by using a GitHub Actions syntax, which is available in these specific YAML files. So we'll start off by renaming our app and use an environment variable that will be equal to our commit hash. Now, this environment variable doesn't exist yet. So we need to make sure that the runner knows what the GitHub commit hash is. We can achieve this by using the environment flag. So we're going to tell it that the environment variable GitHub sha is equal to the commit hash. If you want to know more about the available properties that you can reference, be sure to check out the documentation on github.com. So let's reference the commit hash, and that's it. We can now continue with our next step, which is uploading our deployment artifact. Okay, let's define our next step, and we'll start off again by providing it with a name. Let's call it store artifact for distribution. Next, we're going to use a GitHub action again. Just like the checkout action, GitHub also has a specific action which allows you to upload build artifacts. We're going to use the uses key to reference actions/upload artifacts. This action requires a couple of parameters. So we're going to use with to define these parameters. We're going to start off by the name. This is going to be the name of our artifact that we can use for later reference. For example, in a future step, we want to download these artifacts and we need to reference the name that we define right here. So let's call it app-build. Next, we need to tell the upload artifact action to tell where it can find our file that we want to upload. So we're going to reference the archive file we've created earlier, the commit hash as our file name plus tar.gz. Let's commit our changes to GitHub and verify that everything works. Okay, so our workflow is running. Let me quickly fast forward to the end of the job. Okay, there we go. And as you can see, we now have one artifact with the name app build, and it's a little over 3.6 megabyte. Okay, so now we can work on uploading our artifact to our servers. But at the moment, we don't have any information about our servers just yet. So in this case, I want to create a new JSON file, which will contain a list of our servers with the required information like IP address, authentication like username and password, and a bunch of other configurations. So let's start off by creating a new file in the root of our repository called deployment.config.json. Let's start by giving our server a name, and it's just for easy reference. So when we take a look at the GitHub UI, we can easily spot it. Followed by the IP address of our server. Next, we got our username. Let's enter root. let's set a password as well. I'm going to set it to GitHub Actions for now. Next, we got our port, which is 22 for SSH. Now, I want to be able to set a hook before and after the deployment on each server. So we're going to add a before hook option where we can enter any command that we want to run before our release is activated. For example, we can run a database migration or run a database backup, you name it. And when a release is complete, we might want to send out a Slack notification. So let's create an after hook configuration option as well. Next, we want to set up a server path, which is where our website will be located. So in this case, I'm using Nginx, and I'm going to point the directory to var/www/html. I don't have a server set up just yet. So let's head over to DigitalOcean to quickly configure a server. If you already have a server up and running, that's totally fine. You can just skip ahead to the next part. So let's start by creating a new server. I'm going to use a marketplace image which has Linux, MySQL, and PHP pre-installed. Select the type of server we want to use. I'm going to choose Amsterdam for my region. And I'm going to use password authentication for this example, but I highly recommend that you use SSH keys in production. Okay, so the password that I've entered earlier in the server configuration does not meet the password requirements from DigitalOcean. So let's make this one a bit more complicated. Let's make sure that we also update our password in our configuration file. Okay, so let's leave the host name as it is, and that's it. Let's create our server. Okay, let's copy the IP address and let's see if we can SSH into our server. There we go. That seems to work. Now let's quickly verify that our server can be reached and that our web server is up and running. There we go. That seems to be working as well. By the end of this video, we will have achieved the following directory structure. Now I want to point out the current and releases directories. The releases directory contain the releases that we upload. These are our unarchived artifacts. When the unarchiving is done, we swap out the current directory and point it to the new release. So the current directory doesn't really exist. It's more like a shortcut into our releases directory. So we need to make sure that our Nginx configuration is pointed to this current directory. So let's SSH into our server and make a change to the Nginx server configuration. Let's change the root directory of our web server and append the current directory. Now in our case, we're deploying a Laravel application, which comes with a specific public directory, and we need to point our web server to that directory. So let's append public as well. Let's save our changes and restart Nginx. And if you reload the browser, then you can see that the changes have been made to the Nginx configuration, but that it currently cannot find that directory. Let's update our configuration file with the IP address of our server. In this example, we just have one server that we're going to work with, but you can add as many as you like. Although GitHub does has a limit when it comes to the deployment matrix, in which we're going to talk next, and that has a specific limit of 265. So if you exceed that limit, then you'll probably have to look at a different solution. Okay, so before we can continue, we need to export our configuration file that contains our servers and make it available inside our workflow. In order to do this, we need to add an additional step. Let's create a new step and let's name it Export Deployment Matrix. Now basically what we're going to do is use the runner to load the contents of the deployment configuration file, echo it out to the command line interface, and use a special syntax so GitHub understands that we want to make this information available inside our workflow. Since we want to reference the output of this specific job later on, we want to provide it with an ID. So let's name it Export Deployment Matrix. Next, we'll define our command. Let's create a JSON variable and assign it to the contents of our deployment config.json file. So this doesn't work really well with multi-line JSON files. So I found a piece of code which basically escapes the multi-line JSON file that we have and make sure that it works. So now we're going to echo out our JSON, but we're going to prepend it with a specific name which allows GitHub to read it. So we can do set output. We're going to provide it with a name. We're going to call it deployment matrix. Next, we're going to provide it with the value, in this case, our JSON string. Okay, now we need to tell GitHub that we want to store this information so we can use it for later reference. So scroll back to the top and add a new input parameter called outputs to the create deployment artifact step. Provide it with a key that we can use for later reference. In this case, we're going to call it deployment matrix. Next, we'll use GitHub specific context information that we've used earlier to get the git commit hash. And now we're going to reference steps followed by the ID of our step, in this case, export deployment matrix dot outputs followed by the name that we've provided in the echo statement, which is deployment matrix. Okay, we're all good to go to move on to our next job. In this case, preparing the release on our server. So let's name it prepare release on server. Now we're going to define that this runs on the latest version of Ubuntu as well. Next, we're going to use the needs parameter to make sure that our previous step has been completed. Otherwise, they will run asynchronous. And now we're going to work on our matrix. So we use the strategy input parameter and use the matrix keyword to build a matrix configuration. You can basically see this as a for each loop. The steps that we define in this job are going to be repeated on the objects within inside the matrix. In this case, this is going to be our server configuration. So we're going to load the JSON, which we exported in our previous step, into the prepare release on server step. Okay, so the matrix is going to loop through our JSON file. And we want to provide a name that we can use to reference the information in our JSON file. In this case, we got a list of servers, so let's use the keyword server. The matrix expects a array to be provided. At the moment, we have a JSON string. So we're going to use the function called fromJSON, provided with the output of our previous step. We can do this by referencing up the chain. So we're going to say needs dot create deployment artifacts dot outputs dot deployment matrix, which matches up with the output variable that we defined earlier. Now that we have our matrix set up, we can continue with setting up the steps for this specific job. So we want to start out by downloading the artifact from our previous step. So again, we're going to use a GitHub specific action, which is called action/download artifact. So this action only requires one input parameter, which is the name of our artifact. So let's enter app-build. Let's commit the changes to GitHub and take a look. Okay, so our export deployment matrix step has failed. Let's take a look at our workflow file to see what's wrong. It looks that I forgot a quote. Let's try that again. And there you go. This time it has completed successfully. And on the left-hand side, you can actually see that it has successfully read our matrix, because you can see that it's saying prepare release on servers, and you can actually see that it's referencing server 1 with the IP address. Again, this includes the credentials as well. So in production, make sure that you use repository secrets and SSH keys. Okay, so we got our artifact downloaded. Next, we can upload it to our servers. Again, we're going to make use of a community build action, which allows us to upload our zip file to our servers. First, let's create our next step. Let's name it upload, followed by the users parameter to provide the action that we want to use. In this case, Appleboy SCP action. And by the way, if you want, you can copy and paste the name of your action and just head over to github.com/the name of your action, and you'll actually see the source code of the action which is being run behind the scenes. So here you can see these actions allow for copying files and artifacts via SSH. And on this page, you can see the usage, input variables, and code examples on how to specifically use this action. Okay, let's head back to PHP Storm and provide the necessary input parameters. We're going to start off with the host, which is going to be equal to the server IP. We've got the server IP in our deployment config, so we only need to reference it here. We can use the server object inside our matrix that we define above. So in this case, matrix.server.ip, which will reference the IP address inside our deployment config. Let's repeat this process for the username, the password, port. Next, we're going to define the source, which is going to be the file that we want to upload. So this is going to be equal to the commit hash. So again, we reference github.sha and we append the file extension, which is .tar.gz. Next, we're going to define the target. This is going to be equal to the directory where we want to upload the file on a remote server. So in this case, matrix.server.path to reference the server path that we defined in our deployment configuration. Now let's make sure that our artifacts are grouped nicely together inside a single directory. So let's append the server path with a new directory name called artifacts. This will be equal to var/www/html/artifacts. Let's commit our changes and push them to GitHub. Let's verify that our action is working and that our artifact is uploaded to our server. Let's fast forward to the end of this workflow. There we go. It successfully executed the transfer to our server. Let's SSH into our server and verify that the file is there. So I'm going to check inside our var/www/html directory to see if our file is there. It looks like something went wrong because we only got our index.html. So let's take a look, and it seems that I've got a W inside the server configuration where we define our server path. Let's commit the changes and try this again. The workflow has successfully completed. The upload has been completed. And it looks like that it created the folder in the correct place. So let's check our server, and there we go. Our artifacts directory is there, and it does contain our archive with our current release. Okay, so we got our file on our server. Now we need to extract it so that we have a release to actually work with. So let's create a new step. Let's name it extract archive and create directories. So in order to extract our archive, we need to SSH into our remote server. And we're going to use another action by the same author called appleboy/ssh action, which will allow us to execute remote commands on our server. I'm going to copy and paste the hostname, username, password, and port, since those are exactly the same as in our previous step. Next, we'll use the script input parameter to define the commands that we want to run on a remote server. Let's kick off by creating a new directory that will hold our current release. Let's use the make_dir command to create the directory if it doesn't exist yet. Let's reference our server path, followed by the releases directory, followed by the commit hash. Now this GitHub_sha environment variable doesn't exist yet, so let's make sure that we pass it inside our input parameters for this specific action. So let's set the end flag and let's define GitHub underscore SHA to be equal to the commit hash of this release. The environment variable will now be available inside our runner. But we want to make sure that it's also available, of course, inside our remote server. We can do this by providing an environment input variable for our action. So now this environment variable should be available on a remote server. Let's extract the contents of our archive into the releases directory we just created. We can use the tar command to extract our archive. So let's do tar xzf followed by the path to our archive file, which is equal to our server path followed by the artifacts directory followed by the commit hash of our current release, and of course the file extension, which is .tar.gc. Next, we'll add the -c flag to make sure that the tar command understands that we want to extract the contents into the releases directory, which again is our server path followed by /releases /our release commit hash. Time to commit our changes again and push them up to GitHub to verify that everything works. Let's fast forward again to the output of our workflow. Okay, it seems that our job has failed, so let's take a look what's going on. Cannot find our archive, and it seems that the name is incorrect because those brackets shouldn't be in there. So let's take a look at our workflow. And there we go. I made a mistake right there. The $sign should be before the bracket. So let's change it. Let's push the changes to GitHub and let's try again. This time the job has successfully completed. So let's SSH into our remote server, check the release directory and make sure that our files are there. And there we go. Our Laravel application has been extracted into the release directory. Let's head back to PHP Storm and continue with our workflow. We're going to make some specific changes for our Laravel application. If you don't use Laravel, you can still follow along. We're going to work on something which allows us to share storage between different releases. If you're unfamiliar with Laravel, basically it ships with a storage directory. Inside our repository, this directory is somewhat empty. But on our production release, we might actually have files in there. And of course, we don't want to override our files on our server. So let's make sure that the storage directory is removed from our release so we can link it up to our shared storage directory. So we can use the rm command to remove this directory, which is located in our server path, followed by our releases directory, our release commit hash, followed by the name of the directory, which is storage. Next, we'll replicate the storage directory structure, but outside of our release. I'm again using the make dir command to make a storage directory. Inside the storage directory, we're going to create a couple of new folders which are required for the Laravel framework in order to function. In this case, app, public, framework, and logs. Our framework directory requires a couple of extra directories. Let's make sure these directories exist as well. In this case, hash, sessions, testing, and views. Finally, we need to make sure that the storage directory and all subdirectories are writable. So let's make sure that we provide the path to our storage directory and continue with our next job. So in our next step, we are going to run our before hooks, which allows us to execute any commands before our release is activated. Let's identify our next job by calling it run before hooks. And of course, let's give it a name as well. If you want to make your steps easier to read, you can actually reference your matrix object within the name as well. So for example, we could do matrix server.name to get the name of the server and add before hook. So in the GitHub UI, we'll get server1 before hook, which makes it easier to identify on which server the actual job is running. We're going to repeat a couple of things, of course, again. We're going to make sure that it's running on the latest version of Ubuntu. We're going to define our needs parameter to tell it that we want to have our create deployment artifacts and a prepare release on server jobs to be completed. We're going to reference our matrix again, and let's just copy and paste it from our previous step. Let's name our step run before hooks. Let's save ourselves some time by copying the step from our previous job to execute a command on a remote server. Next, we'll add the script tag again, followed by the before hook from our server configuration by referencing our matrix object. So let's do matrix.server.beforehooks. Inside our server configuration, we can now define our before hooks. These before hooks will be executed before we activate the release. So you might like go into a certain directory and execute a command. It would be pretty nice if we don't have to do things like var slash www, etc. But that we can reference a environment variable, which makes it a bit easier for us. For example, we could do cd release path in order to get in our current release directory. This won't work just yet. We need to make sure that the environment variable actually exists. So let's define our environment variable, which we called release underscore path. We'll reference the server path followed by the releases directory followed by the directory name, which is equal to our release commit hash. Okay, next we want to set an environment variable that we can use to reference the path to our active release. So let's name this environment variable active underscore release underscore path, followed again by the server path, followed by the current directory. Next, we also have a storage path, which is the path to our storage directory, and the base path, which is nothing else than our server path. Now let's make sure that these environment variables are actually available on a remote server by again going to the input variables for our SSH action and defining the ends input variable, followed by the environment variables that we want to make available. In this case, our release hash, our release path, our active release path, our storage path, and our base path. Now we of course want to make sure that this actually works. So let's head over to our deployment configuration and echo out the GitHub commit hash. Time to push our change up to GitHub and take a look. It seems something went wrong. The workflow is not valid. Job run before hook depends on an unknown job prepare release on server. So let's take a look. And it seems I've got an S right there. Let's try again. This time our workflow has successfully completed. Let's verify that our commands have successfully executed. That looks good. Let's verify on our server and our storage directory is there. And you can see by the green highlight that the write permission is set correctly. Next, we got our before hook. Let's open it up and there you can see we echoed out the GitHub commit hash, and on line 30, you can see that it is equal to 884, etc. So that is working as well. Our environment variable is available on a remote server. Now it's time to work on the most exciting step, activating our release. Let's just copy and paste the run before hook step, since the active release step is going to be a couple of SSH commands as well. Let's rename it to activate release. Of course, make sure that our run before hooks has actually completed before we run this job. Change the name to activate release as well. Let's change the step name. Okay, I think I spotted a mistake that I made in the previous job, and there should actually be a single $sign instead of two. So let's make sure that we update this across the file. I think we got them all. Let's replace it with a single $sign and two brackets. Okay, so now we want to make sure that our current directory is pointing to our new release. We can do this by symlinking. We're going to symlink the current directory to the directory that holds the current release. We'll use the ln command to set up a symbolic link. The -s flag means it's a symbolic link. The -n flag tells it that it should treat it as a normal file or directory. And -f tells it to force or override a link if it already exists. This is then followed by the path to our new release. And we want to make sure that it's linked up to our /current directory, or as we referenced before, as the environment variable active underscore release underscore path. In case you are using Nginx with PHP FPM, you need to make sure that PHP is actually reloaded. Otherwise, it will not pick up the changes when we swap out a symbolic link. So we'll do this by doing servers PHP 8 FPM reload. Time to verify that everything works. So let's push this up to GitHub and take a look at our job. In this case, it has successfully executed the commands on our server, it has set up the link, and it has reloaded PHP 8. Let's verify this on our remote server. And there we go. As you can see, our current directory is currently symlinked to the release that we just deployed. Let's cd into our current directory to verify that our application is, of course, actually there. And there you go. If you would head over to our browser, you can see that it isn't working just yet. This is because we still need to set up a couple of things in order for this Laravel application to run successfully. If you're unfamiliar with Laravel, it ships with a environment configuration file. This file basically contains things like the application name, the URL, database settings, etc., etc. This file needs to exist and needs to have a couple of configuration options defined in order for the framework to work. Let's kick off by creating an environment variable. Let's call it Laravel_env. And let's make sure that it equals to the Laravel env secret. Secret, again, is a keyword that is context specific to this GitHub action, and we can define our secrets within the GitHub UI. So head over to your repository, go to settings, secrets, new secret. Let's enter the same name that we defined in our workflow file, which is Laravel_env. And I'm just going to copy and paste in a example environment file that ships with Laravel. And I just changed the app name and the environment to production. Now during each deployment, we want to make sure that our environment file is updated. It doesn't exist right now, so let's make sure that it does. We will use the printf command to echo the contents of our secret into our environment file, which is going to be located in our base path /.env. Of course, this file needs to be inside our release. So we're going to use the link command again, but this time we're going to link the environment file from our base path to our release path. Now you could argue, why not create this environment file inside the release directory? Well, that will result in a lot of environment files scattered across all our different releases. I prefer to have a single file which is a single source of truth. This makes it easier to work with. Since we're here, let's link up the storage directory as well. We'll use the ln command and reference the storage path, followed by the release path, which basically means that we now have a storage directory available in a release, which is symlinked to the storage directory inside our base path. Let's trigger the workflow and verify the results on our server. Okay, everything is successfully completed. Let's take a look at our website. And unfortunately, it seems that it's still not working. Let's go back to our server and take a look. Our files are there, the end files is there, it's correctly linked. Current directory is there, but the environment file is empty. Let's see, our Laravel env is defined. I've got to pass the environment variable to our remote server. So let's give this another try. Okay, our workflow has successfully completed, but it's still not working. Let's verify that our environment file is there. Okay, that seems to work, but it's not yet working. Okay, I quickly paused the video for a second. I forgot to update my Nginx configuration. This server is provisioned with PHP 7.4, which I upgraded to version 8, but I forgot to update the Nginx configuration that was still referencing to PHP 7.4. So let's change it, reload Nginx, and try again. And yet it's still not working. Let's dive back into a server and check the error log. So Laravel is complaining about the fact that we provided a invalid cache path. So it seems that I forgot to create a additional directory inside our storage framework /cache directory, which is a data directory. So let's quickly create this right here. Make sure that it has the correct file permissions and refresh. And there you go. We have successfully deployed our Laravel application. So we've manually fixed it on our server, but of course you want to make sure that it is fixed in our workflow as well. So let's head over back to PHP Storm, scroll up, and let's make sure that the data directory is created inside the cache directory. Let's copy and paste our previous command and let's adjust it accordingly. Okay, next up we got our after hook. So to make things a bit easier, let's just copy and paste our before hook since it's almost the same. Let's make sure that our activates release job has finished before we trigger the after hook by adding it to our needs array. Next, we'll update the identifier to run after hook. We update the name as well and the name of the step. And finally, let's make sure that we reference the after hooks from our server configuration. Okay, great. Our after hook is done as well. Let's continue with a little bit of a cleanup. Every time this workflow is triggered, it will upload our artifacts. Now, if you do this 100 times, this will mean you have 100 artifacts, and these artifacts take up disk space. And you probably don't want to end up with your server crashing in the middle of the night because it has run out of disk space. So let's make sure that we clean up the releases and artifacts directory. Let's copy and paste our run after hooks job and let's make some changes. Let's change the identifier to cleanup, update the name accordingly and the step name as well. And of course, make sure that our after hook has completed before we are running the cleanup. We don't need the environment variables that we created earlier, so let's remove them and replace them with 2 new environment variables. We want one environment variable to reference our releases directory and another environment variable that references our artifacts directory. Now we need to make sure that these 2 environment variables are passed to a remote server, so update the env input variable of our SSH action. Let's cd into our releases directory and list all the releases by time and date. Next, we'll use the tail command to offset this list by 5 and return any remaining directories that might exist. We'll use the remove command to remove any directories that are returned by the tail command. Now we want to replicate this behavior for our artifacts directory as well. So let's copy and paste this line and update the environment variable to reference our artifacts path. Time to commit this to GitHub and trigger a workflow to verify if this works. Let's fast forward again to the output of our workflow. So our commands have been successfully executed on a remote server. So let's verify this by listing our releases and of course our artifacts as well. And as you can see, there are 5 remaining of each and all the additional files have been removed. That's it. We've successfully deployed our Laravel application to a remote server without any downtime. In this video, we've used a single server when we deploy our application. I've duplicated the server that we've been using 3 times, so we have a total of 4, and I've updated our server configuration to include these additional servers. By default, GitHub Actions run in parallel, which is quite nice as you can see right here. It's executing the prepare release job on all our servers simultaneously. Now to see this in action, I've also updated our Laravel application to include the server name on the welcome page. So if we take a look, you can see that the documentation title has updated to server 1, server 3, server 2, and server 4. I hope you enjoyed this video, and if you'd like to see more of these, be sure to support me by clicking the like button and subscribing to my channel. I truly appreciate all the support. Oh, by the way, if you have any questions, drop your comment below and I'll get back to you.